In this video, I want to introduce what quantum theory is and describe some of the basics of quantum theory. And by the end of the video, you'll be able to explain what the relationship is between quantum theory, light and energy, and atomic structure. So let's talk a little bit about Max Planck. Max Planck, around the turn of last century, was heating up objects, just all sorts of stuff. And he noticed that as things heated up, they emitted light. It's called black body radiation. Okay, it's like an incandescent light bulb. Okay, and what he decided, or what he concluded from this, is that energy in the form of light is emitted in very specific amounts. Okay? And that specific amount we call quantum, or quanta is a singular. Okay? A quanta is plural, quantum is singular. And so the quantum is the minimum amount of energy change that is required to emit that light. Okay, now that's a lot to understand, but here's the idea. Okay, and this is how it relates to atomic structure. We understand that electrons kind of orbit around the outside of the nucleus. The nucleus is very, very tiny. It's in the middle here of this, right? Here's the nucleus. Okay. And then the electrons, they don't actually orbit. The Bohr model is not the right model, but for this explanation, it is the best way of showing you what the heck happens. And why it's a quanta. Okay, now, if we have an electron here, okay, actually I think that I have, if I go here, if I have an electron on here, okay, and then we add energy, that electron goes to the next energy level. It goes to the next place available to it. Notice the electron can't go in between. And that's the idea of a quanta. The electron can be here or it can be here. It can't be in between. So if an electron is going to go from here to here, it needs to have at least this amount of energy. If you don't apply the amount of energy required to get all the way up to this second orbit, it's going to still stay in the first. Okay, so that's what we mean by quanta of energy. And the same thing can happen as the electron moves back down. Okay, it releases quanta of energy as the electron moves this way. Okay, and so the idea here, what ends up happening is, instead of having just, well, if it releases, whatever, I'll just make up a unit here. If it releases 5 energy units, okay, and if it's a continuous theory of matter, continuous theory of energy, that means that whatever, that energy is going to go up to here. But because it's quantized, and if we apply 5 units of energy, well, that's in between the two places, so that electron is still going to stay right here in this quantized energy level. And that's the idea of quantum mechanics, okay? Is that we're talking about electrons that don't move kind of continuously around, but they're kind of forced to stay in one spot unless you add a specific amount of energy. So if you add enough energy here, let's say it's 10, okay, and let me label these with, again, I am just using random, amounts of numbers here. I'm not actually assigning values to these that make any sense other than just to illustrate a point. But let's say this is then 17. Okay, let me try to get rid of some of this stuff here. So again, to illustrate the difference between the continuous and quantized theory, if I add 12 units of energy in the continuous theory, it's going to go up to here. Okay, in the quantized theory, which is our best guess of what's going on here, in the quantized theory, the electron is going to move. It's going to kind of move up here, and it's going to stop here. It's only going to be able to get up to the 10. There's not enough energy to move it up here. It's kind of like a ladder, okay? And actually, that's kind of interesting because here we go, okay? You have your electron, and the electron, instead of being able to fall down and roll down a hill, what ends up happening is your electron will move stepwise down. And notice at no point can that electron actually stop in the middle of one of the stairs. It has to stop on the top of the stair. Okay, so we can watch it one more time here. Okay, there it is, stopping in the middle of a stair. It can't, or stopping on top of a stair. It can't stop in the middle of a stair. And that's what quantized energy does. And so what does this have to do with light and energy? Well, it turns out that Max Planck guy, like if we have an atom, let me just move forward really quick here, okay? If we have an atom, this is the same idea that we just went over here, okay? If we have an atom, this is the formula that you hopefully already know. There's the nucleus, and here is the orbit of an electron around the nucleus, okay? If we add energy to this, okay, the electron will move up, okay? It'll move away from the nucleus. How do we add energy to it? Well, we can add light, or we could add UV, okay, UV, or infrared, or radio waves. But by adding energy to the atom, the electron will move up as long as it has at least the minimum quantized amount of energy. Now, even more interestingly, possibly, is that if you have an electron that is already up, okay, the electron's already up here, and now that electron moves back down, okay? Now, if it took energy to move the electron up, well, when the electron moves back down, energy, as that electron moves down this way, energy is going to be released. And guess how energy is released? Energy is released in the form of wavelengths of light or UV or radio waves or gamma rays or whatever. And so this is how in the sun, when you have a whole boatload of energy, the electrons are released as they're moving back and forth. It's releasing energy out into space, right? Okay. There's also that whole nuclear fusion thing, but okay. So this is how wavelength and frequency is related to atomic structure. Okay. What do we know? As the amount of energy increases, the wavelength gets smaller, the frequency gets bigger. Okay. Well, how do we get more energy, or how do we see that? Okay. Let's just really quickly erase this thing here, and I will show you kind of the neat stuff. Okay, so let's take an electron, and now I'm going to abbreviate this. So let's take an this is the nucleus, and then we have the atom. Now I'm only drawing the parts of it. Realize that this is going to go around, this is going to go around. But so we're going to take an electron and we're going to move it here. We're going to add a whole boatload of energy. Okay, so the electron goes up 1, 2, 3, 4. Okay, well, so we've added a whole bunch of energy. Well, what happens when it falls back down? When that electron then goes from here back down, I'll do this in a different color here, it goes from here back down, it releases a whole bunch of energy. Okay, so however far it moves, the further it moves, the more energy, and then the more energy, the smaller the wavelength and the greater the frequency. So all of these properties of light and energy, or of light waves, of photons and all this stuff, are related to the atomic structure. So that gives us that kind of relationship. So it's pretty interesting stuff. So I hope that you enjoyed this video.